Hello, let's continue our Sudoku adventure with Buffoon's Balloons by GDC. So we have normal 6x6 Sudoku rules. That means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these rings in the grid. It's called lines in the rules, but they're like rings. Now, to be clear, the rings don't touch the middle cell. They all touch exactly 4 cells. So even though this one here looks like it might be intersecting the middle cell, it is really just a ring that goes around that middle cell. And there's 2 row sets. There's run band and region sum lines. The run bands are a set of consecutive digits, but in any order. So, but they can't repeat, right? So it's a set of 4 digits that are consecutive with each other. So like 1, 2, 3, 4, or 2, 3, 4, 5, or 3, 4, 5, 6. Those would be the options for a 4 length. So let's say this was 2, 3, 4, 5. The order doesn't matter though. I could put a 2 here, a 3 here, a 4 here, a 5 here. We're not in any specific order, and that's perfectly fine. What I can't do is make them 2, 3, 4, 6, because then that would not be a consecutive set of non-repeating digits. All right. We also have these region sum lines in the grid. What you do is you divide those up by box. So like these 2, we can color green, this purple, this blue. What we say is the sum of the green cells is the same as the sum of the purple cells, which is the same as the sum of the blue cells. Now, that just means that purple and blue are the same digit as each other in this case, and green sums to them. Yep, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, I want to start with this one here, because this is split up like this, with this would be green, this would be blue, right? So the green cells add to the blue cell. It's kind of like an arrow in that way, right? With an arrow circle there, and then the arrow going through these 3. So 3 cells, the minimum you can put in them when they can't repeat because they're on the same box is 1, 2, 3. Which adds to 6. 6 is the biggest that I can put in here. So because this is the minimum and this is the maximum, they kind of meet in the middle and say, hey, we have to be 6. So this is what it has to be. 1 plus 2 plus 3 is 6. We just said that this cell is the same as this cell, so these are the same. In fact, if I just color that green, that'll remind me. This is the same thing. This is a 1, 2, 3 adding to 6. Okay, so yeah, I should have seen that these had to be 3 already, but now it's very clear that these 2 sum to the green, right? And so they have to be 1 plus 2 summing to 3. So we get those digits. These aren't 3s. That places this 3. We don't need this green anymore. And I think that takes care of the region sum lines pretty much. Now this 1, 2, 3 is on a Ren band, so that has to be 4 to make that consecutive. This just has to be, these both are from 4, 5, 6. Sorry, they're from 3, 4, 5, not 4, 5, 6. This sees the 3 and the 4, so we can place the 5, the 4, and the 3. For here, that's just not a 3. Right, I could just pencil 4, 5, 6 into these. Might as well. 4, 5, 6. We can clean that up a little bit. Ah, this is a 6, so it sees 4, 5. That's helpful. These 2 6s look up. So 6 is over here, but oh no, 6 is placed here. I was going to say, can we put 6 on here? But actually, Sudoku already tells us we can't put 6 on it. Oh, but actually, where does this cell go in the box? We'll call that green. So where does green go in this box? Well, it doesn't repeat in the column. It's not 3 or 6, and it can't repeat on its Ren band, because Ren bands don't have repeated digits. So it has to go here. This is the 1 or 2. But I guess Sudoku told us that anyway. Oops. Okay. We didn't need that. But it was fun. Now the question is, what's this missing? It's missing a 1 or a 5. It definitely has a 4 in one of these 2 cells. But yeah, this middle cell here sees the entire ring. And the ring is either going to be 1, 2, 3, 4 or 2, 3, 4, 5, which means it's either missing the 1 or the 5. And that missing digit goes here because it can't go anywhere else. And I guess the 1 could go there. But this can't be, it will see 2, 3, and 4 on the ring. So this cannot be 2, 3, 4. So it could be 1. It can't be 2, 3, 4. It could be 5. It can't be 6. So it is from 1, 5. And it is the missing digit from the ring. Does that mean this can't be 1? I think this could be 1. Yeah, this could be 1 if this is also 1. Yeah, that's fine. I was thinking 1 might exclude 1 from the ring, but no, that's not true. All right, this is a 1, 2 pair. So this is 4, 5. That's a 4, 5 pair there. So this is a 1. So the ring is missing 1. These are 2s. That's a 1. That's a 1 and a 2. This is 4, 5. Don't need the corner marks. We have a 3, 4, 5 here. So this is a 1 for the box. This is a 2 for the box. This is 5 or 6. Let's just pencil the rest here. We've got, actually, what are these? These are not 1. So these are from 2, 3, 5, 6. Because the 4 is in the box. These are from, these are from 1, not 2. Could be 3, can't be 4. Could be 5, can't be 6. 1, 2, 3. 1, 2, 5, 6. Okay, yeah. If we color these 4 5s, I see what to do. Whenever you get a bunch of pairs like this, it's often beneficial just to color them. So if I make this green, what that means is I don't know which of these is 4. I don't know whether green is 4 or green is 5, but we're defining whatever goes here as green. So that means this one cannot be green. We're going to call that purple, right? Because purple is going to be different than green because they're a 4 or 5 pair. And so purple is the different 4 or 5 from green, which means that this has to be green. This is the same digit as green because it has to be different from this purple. And that means this is purple because it has to be different from this green. We can also mark this one purple if you prefer, or in addition. And so now we have a bunch of cells that see a green and a purple. This cell sees this green purple, and this cell sees this green purple. And so how could they be green or purple? Well, they can't. This can't be purple because it would share a row or a box with the purple. It can't be green, share a column with a green. So it can't be 4 or 5 at all. It must be 3. Same with this. This can't be 4 or 5 at all because it can't be green or purple. Which actually does mean purple is here, right? And so that you can see what's going on here. This ends up as 6 because it can't be 4 or 5. That does make all the purples 5, and it makes all the greens 4. And then now we can finish the puzzle. So that's 1. Sorry. That's 1, that's 2, that's 3. That's 2, 5, 6. That's a 1, and we're done. Nice. A little bit of coloring at the end there. There might have been other ways through, but coloring the 4 5s definitely did it. It wasn't that hard to see that these 4 5s were different, and I just wanted to show it with coloring. It was cool to see that also affected this cell, and also we could ask where purple went in here. You could get a lot of the coloring done before finishing the puzzle, but that was definitely enough, more than enough to finish the puzzle. Cool. Well, thanks, GDC. That was a neat puzzle. I enjoyed it. Hope you enjoyed it as well. If you did, then why don't leave a like, subscribe, and a kind comment below.